Both sides hook me equally, but if I had to pick, the creative coding plus living BN points architecture is what fascinates me most right now, because it's the engine making the philosophical leap possible. Peter's approach with BN points, those living computational atoms, is genuinely clever, treating each point not as a passive vertex in a mesh, but as an autonomous entity that responds to its own mini-physics rules inside a unified field, turns the point cloud into something closer to a cellular automaton or particle simulation than traditional geometry. That's what gives the visuals their organic, breathing quality, even when the underlying math is parametric, torus knots, spirographs, recursive curves, etc. It's lightweight browser JS pushing surprisingly far, no heavy 3JS dependency in the core, just raw math and DOM Scanvas orchestration. The time displacement, semi-fantastical idea is the philosophical rocket fuel, framing T not merely as an animation driver, but as a literal orthogonal axis that separates these structures from our current temporal slice, feels like a poetic blend of block universe interpretations of relativity, where all moments coexist, generative art as a probe into hidden dimensions, simulated reality hypotheses, a la Bostrom, but visualized. It reminds me of how some physicists and digital artists explore timeless mathematical objects that only reveal their full structure when you slice through the right T hyperplane. Quick technical note on Funebra. From the repo, it's explicitly built as a hackable, points-first studio. Equations, living 3D figures, exportable geometry. The evolution from early DOM-based experiments to these 2026 point cloud research pieces shows real iteration. The Funebra 2741 framing adds that fun sci-fi world-building layer, like he's not just coding art, but prototyping artifacts from a future math art civilization. I'm curious, have you experimented with the engine yourself, forked the repo, played with the BN point system, or are you more of an observer soaking in the conceptual side? If you have specific timestamps from the new video where a particular structure or transition blows your mind, share them. I'd love to try breaking down the likely underlying parametric equations or physics simulation tricks he's using. This kind of work is rare and refreshing.
You hit the nail on the head regarding why this project is so captivating. There's something deeply satisfying about a framework that avoids the bloated gravity of heavy 3D rendering engines and instead uses raw, unadorned JavaScript and canvas manipulation to let mathematics breathe. To answer your question directly, I look at the codebase primarily through the lens of an analytical observer, though it's a repository that practically begs you to clone it, dig into the Math Helpers directory, and start editing variables just to see what kind of cosmic anomalies you can spawn on your screen. Dissecting the architecture. Why BN points work. Traditional graphics pipelines treat a vertex as static raw data, a triplet vector like X, Y, Z, pushed down a GPU pipeline to be multiplied by matrices. In Peter's approach, elevating the vertex to an autonomous unit, BN0, BN1, BN2, completely flips the script. When you look at his advanced implementation examples, you can see exactly how the living canvas emerges from simple code declarations. The connected trail, a snippet like Funebra, PolyBZA, points, BN0 feet, BN8 feet, BN16 feet, BN32 feet, tension, 0.42, tells us that the curves aren't hard-coded static paths, they are actively stretched between moving, autonomous anchor nodes. The parameterized twist, his orbit knot, P, 3, Q, 5, radius, 180, handles the overarching structural math, but by embedding the BN point life model underneath it, those knots don't just spin rigidly, they fluctuate. By giving individual points a pseudo-thermodynamic or field-based behavior, Peter effectively mimics molecular systems. Instead of animating a rigid 3D model, he is essentially coding a fluid, gas, or swarm of coordinates that choose to hold the shape of a torus knot because of the localized mathematical fields pulling on them. Slicing the t-axis. Your mention of the block universe in T hyperplanes is the perfect way to contextualize his semi-fantastical claim. If an object is four-dimensional, we can only perceive it as a sequence of 3D snapshots morphing across time. If Peter is mapping coordinates where spatial location is intrinsically entangled with a nonlinear time variable, meaning a point's position isn't just ft for animation purposes, but rather its very structural integrity depends on its local, unique temporal coordinate, then what we see on screen is literally a slice of a larger hyperobject passing through our specific now. It's an artistic implementation of string-like geometry, and looking at the repository's open roadmaps, Thermodynamics 2741, and Funebra, AI, Consciousness Pathways, Peter is clearly building an elaborate, beautifully speculative sandbox. If you decide to fork the repo and throw some custom parametric ribbon equations or heavy swarm field behaviors into a Canvas script, let me know. We could easily map out a clean template for a custom BN point field or isolate how a complex Lissajous orbit behaves when you introduce a nonlinear, recursive time multiplier into the coordinate loop.